I'm sure you've all once spent hours looking for a simple solution to video chat with a friend over the internet, but only found complex solutions. This is going to change. Here is WebRTC, a communication protocol, explained in plain English. Hi, this is Jack. Hi, this is Alice. Jack and Alice would like to communicate over the internet. For Jack, being a computer guru, this is a simple process that only takes seconds to set up. But for Alice, who knows next to nothing about computing, this seems really difficult. Jack comes up with a few solutions that he asks Alice to try out. But to use Skype, she needs to download and install the software. To use Google Hangout, it's the same story once again. You need a Google Plus account, you need to install a plugin. A lot of solutions, but they all require a lot of effort for just a simple task. Thankfully, Jack knows a lot about computing, and he's got one last trick in his hat: a browser-to-browser communication protocol called WebRTC for web real-time communication. Real-time communication is difficult both to set up for a developer and to use for a client without the intervention of external plugins or software. That's why WebRTC was created, to enable real-time data transfer natively through browsers. Let's get a sneak peek into WebRTC. It's composed of two layers: a first layer for web developers offering all the tools to create an application for the end user, and another layer used solely by browser makers to enable WebRTC on their respective browser. Let's go back to Jack and Alice. They want to do a video call on the WebRTCchat.com website. First, they both stumble upon a message asking them to specify the camera they will each be using. Then, a virtual pipe is created to exchange the unique session information between them, which will open a peer-to-peer connection between the two users. Now we have a fast, low latency and direct communication between our two friends. Although this is a peer-to-peer connection, a server is still required for user discovery process, signaling, and the NAT firewall traversal. Signaling, the process of exchanging metadata before the communication can take place, is done over a WebSocket server. The metadata relates to the camera resolution, codecs configuration, network requirements, and so on. Meanwhile, ICE, a framework that handles the NAT crossing to connect peers, will choose the best suitable path for the connection from a pool of routes. It will try with a direct UDP connection first, using a stun server to get the global IP address and internet port of the client, usually hidden behind a NAT or a firewall. If UDP fails, it will switch to TCP using the HTTP protocol. If all of this doesn't work, it will choose to go through a term relay server. Eventually, the data can freely navigate through the designated path. For Jack and Alice, that's how easy it looks for them. WebRTC also comes with a bunch of integrated network, sound and image enhancement that all work in real time, such as noise reduction for the sound and image, jitter and packet loss control for the connection. For those of you who worry about security, unlike regular communication, the data that is being shared between the users is installed on a gateway server. Don't worry, the NSA won't be sniffing into your data just yet. Thanks for listening. This was WebRTC explained in plain English, created by Jordan Martin and Jonathan Taws.